All right, let's see. We should be up live now. Let's see. Sure, great. Hey, everybody. Welcome to our midsummer AngularToronto meetup. I'm very excited to have this meetups, even though we cannot meet in person. But I'm very happy that we can, there's at least a virtual format that we can do. However, with the virtual format, it also brings us another advantages. We can now have speakers from all over the world, which we kind of do for this meetup. We have Fabrice from Norway, we have Kate from States, and we have Nicholas from Australia all the way there. That would be almost impossible to fly in Toronto, although we should probably try that sometime. Anyhow, super excited for this one. Let me just go over some of the intro slides that we have and get it going. All right, so here's the slides. Great, so this is our July 21st edition. Sorry that we had to move it for a week, but we had some situation that we had to adjust it for a little bit later, and hopefully it works out well for everybody. In-person event or online, we do have a code of conduct. So please do not harass any of the participants, speakers, but next to each other in the chat. We'll also bring a few of you for live questions. Make sure everything's fine during those times as well. I'm taking some risk, but hopefully I will have a great audience and we can do this. Then we'll start off with Fabrice Simoni, who will tell us about the schematics and the practical introduction with them. He's a co-founder and senior developer at K30 Group AS. Then that will be followed by Kate Sky presentation about the clean code with the container presenter pattern. And followed after that, we'll have Nicholas Jameson, who will be showing us how to improve developer experience with RxJS tools. Let me bring all four of them right now here. Hey, everybody, they're all here and they're ready to share their knowledge. All right, so back to our presentation. So, that's me, organizer here, and Fernando Gil as well, helping me out. And the other thing that I want to say, big thanks for our sponsor, Narwhal. They are an ongoing sponsor who's been sponsoring us since our beginning. Thank you so much for enabling these meetups. Otherwise, we won't be able to do it. So definitely check them out. And also, I'd like to say thank you for Firebase and Google for allowing us either to use their venues, or right now sometimes I use some of the time of Firebase to talk about having these meetups. We have a few announcements. First of all, Angular 10 was released last month. This is, by the way, picture by Minko Getchev from Angular team. There are a few things that were released. It wasn't a big release. V9 was a huge one with Ivy enabled by default. This one is, there's a few things like date range picker got there. You can generate the new Angular project with a strict flag that enables a bunch of strictness, including in templates. And Angular team also announced that they had a major fix-it that touched almost like 2,000 bugs during this time. So those are the big announcements there. So RxJS 7 data was also released at version 2, I think. They also went over a lot of bugs. So I think it's getting closer to the actual final release that they can do soon. And JRX team been working hard on a lot of things, including component store. So please install it and try it out, and we'd love to hear your feedback. We're getting really close to being finally able to release it together with our JRX V10 release. So that's all from the announcements. Let's get back to our speakers, and we'll start with Fabrice Simoni. So Muni, who will tell us all about the Angular schematics. Yes. There we go. And oops, there we go.
All right, am I on? A sec. All right, looks like I'm on. All right. I hope everybody can hear me. All right, my name is Fabrice Muni. I'm calling in from the north of Norway, where the sun doesn't set, where I'm visiting my mother for the holidays. And today I'll be talking to you about Angular schematics. And a little background, I have been working with Angular since the AngularJS times, but professionally since Angular 2. And I don't consider myself an expert in a way. I like learning, I dig deep. And I've been wanting to learn about schematics for a while now. And it's been a tough ride, but I noticed that when I have purpose, then it's easier to learn. So while working, I came to a situation where I was doing a lot of manual steps each time I was starting a new project. And these steps involved creating a new project, applying strict compiler settings, adding prettier config, style, lint staged, Husky, and lately Web Vitals analytics, and so more. And I just kept doing this stuff all the time, and things change, and there's some inconsistencies. And so I wondered, how can I make this process repeatable and basically automate it? And one option was to have like a base project, which I can base things off. But another one is actually creating a schematic that I could apply to my projects and then have it basically apply or whatever settings that I need to apply company-wide. So in this talk, I'll just go through the first 3 steps. So basically creating a new project using the Angular CLI, applying strict compiler settings, adding prettier to and the accompanying configurations. All right, so anybody who's used the Angular, who's created an Angular project before knows the engineer command. What's new is the -- strict that Alex was talking about. So this took care of some of my requirements, which is basically applying the strict TypeScript settings and Angular compiler settings. And basically, this is an extract from a typical tsconfig file. I want all the highlighted properties to be set to true. Some of them are standard, like strict, true, but no unused locals, no unused parameters are some things I want on top of what's provided by the -- strict flag. Prettier, the basic steps of adding it is adding it as a dependency, and then adding the configuration either through package.json or the multiple ways of doing that. In my case, I just prefer having the prettier .prettier.rc and prettier ignore files. All right, let's go a bit deeper. So what is a schematic? From the Angular documentation side, it says a schematic is a template-based code generator that supports complex logic. It is a set of instructions for transforming a software project by generating or modifying code. So according to my requirements, I have an existing project. I want to transform it to meet some kind of standard that I've set. So I'm thinking, okay, this suits me perfectly. All right, so how do you get started? Again, by digging through the documentation side, I found out, okay, the schematics actually have a CLI, which you can install globally. as shown on the screen, and then you just run schematic. Blank is a template basically, and the name of the schematic you want. In this case, you are creating a blank schematic called hello world. All right, so when you run that command, this is what's generated. This again is straight from the documentation side. You can find it there. So a schematic is basically a project that's a collection.json file that's kind of a manifest of all the existing schematics in the project. So if you look at this image here, we have a factory property under hello world that points to the hello world function inside the hello world directory and the index file. So you could add more schematics to the project like this. And if you look at projects like Angular, if you dig to the source code of Angular or Angular components or NGRX and look at their schematics, you'll find a similar structure like this. And I highly recommend to do that. It's a very easy way of learning how to use schematics. All right, when you write a schematic, so in this case we have a hello world schematic, you have a few concepts to kind of be aware of. You have rules and you have actions. So every schematic is basically a function, which is a rule that returns a function that takes a tree and a context and returns another rule. And the property of the rule is that it is what's the word? It is a pure function, basically, which means you can compose them in multiple ways. A tree is a representation of the file system on your disk of your project. And by the way, schematics are not Angular specific. They can be used in other projects. It just so happens that Angular has basically built schematics into the CLI, which enables us to use them for transformations in Angular projects. Context is just an object that gives you some properties to manipulate the tree, or some functions to manipulate the tree. All right, so let's say I've already published my schematic on npm under k30-angular-starter. And if you want to add this to your project, you have to run ng-add and then the name of the library for it to be added to your project. I'm pretty sure you're familiar with this through other libraries like Angular Material, for example. These basically follow the same principle. All right, so once you generate the schematic, you usually get a build and a test script. I've added the build watch, which enables me to basically rebuild my project as I'm changing it. So it is a nice thing to add there for reference. All right, so you run yarn build watch to basically get you get a rebuild, and then to actually test the schematic, you run schematic. This is basically the global schematic you've installed. And then the starting period is basically pointing to the project you have. And then the ng-add is the schematic you want to run. So in our case, when you do ng-add, it's actually going to look for a schematic called ng-add. It's a basically specific schematic. You know you can have other schematics. So when you do ng-generate, that's another schematic. So there's different types of schematics. But in this case, when you're adding a new library to your project, you use ng-add. There's also the ng-update for updating schematics and with migrations and stuff like that. All right. So as I said initially, the way I found worked for me, this is for me, is having a goal helps you kind of narrow your focus on what you want to achieve, because there's a lot you can do with schematics, and a lot of the stuff is not well documented. So there's a lot of articles around on the internet for how to do different things. But when you start with the goal in mind, it becomes easier for you to know where to look. So in my case, I'll basically look, okay, I want to basically go from a new project and transform it to something. And then I'll have to think back, okay, when was the last time I did that? Then I remember, okay, last time I created a project, added and I added another library through ng-add. I'm okay, then let me look at that library. In most cases, Angular material. Then I look at their schematics and say, okay, how are they doing things? How are they modifying things? Then I have that as a basically as a stepping stone to achieving what I want to do. All right, and here I just linked to a couple of articles that helped me getting started. I would recommend you to read them in the provided order. On top of that, as I said earlier, read through the source code of other existing schematics. You're going to learn a lot about how to use them correctly and what they're supposed to do. And then schematics also provide a lot of utility functions that were used by Angular, and then they were basically open sourced or basically provided through the public API, which makes it easier to manipulate the workspace files and anything basically you would like to do. These are pretty low level, but so far they are the things I could find to help me achieve what I wanted to do. All right, let's look through some code. All right, so I have a project here. So I've generated as a schematic project. As you can see, I have a collection JSON with an ng-add schematic. This is the one the Angular CLI is going to look for when you do ng-add. And as I say, this lives under ng-add index, and it's calling a function called ng-add, or a rule called ng-add to be specific. So if I go into ng-add here, I have a bunch of files that have been generated from running this. I could remove them, but it's the same thing. So if I look at the index.ts, so this is basically how a rule looks like. You have an ng-add, it returns a function which takes a tree and a context. And in this case, I just console log the tree, where in this case, because I'll be testing in the schematic project, I can actually show you how to read files in the schematic project. So if you look at the schematic project, I have a README file here. And when I run this, so I'm using tree.read. I'm passing in the name of the file I want to read. And if this one nested, I would just have to do Unix type nesting to read the file. And then the first part here returns a buffer, and I convert that to a string. So in this case, I can run this quickly, show you. So I'm calling schematics, the ng-add schematic. All right, and then basically in the terminal, I can see the contents of the README file. I could change this to something else just to show you. Wait, let me try on block. It's a good idea. Oh yeah, of course, I have to rebuild this in order to run, because now it's running with the old build. So if I do yarn build watch, it's referencing this here. That's been built. If I run this again, you see now that I got the output of the yarn log file. All right. So let's through my first case. I wanted to apply strict settings. By strict settings, I'm gonna just re-enable that. I'm gonna comment out this. I have an new Angular project here called ng9. I can do a git status. So some changes, I can move changes there. Git status, there's nothing in there. If I look at yes, config base, So you have the strict true, which comes by default when you use the dash strict for command or flag. That's it. And then under the Angular compiler, you have these two. Remember that I wanted to add some more. More things to the test config. For example, no unused local. So let's just dive deeper into this function. All right. So in here, I'm basically doing a couple of things. I'm reading the tsconfig base JSON. Remember, now we are in the context of an Angular project, right? So I can assume there is a type tsconfig base JSON in the top level of the tree. So I read that. That gives me a buffer. Assuming everything is good, I use an utility function, parse JSON AST from Angular Dev Kit core. And this basically gives me the JSON, the tsconfig JSON as an abstract syntax tree. If you don't know about abstract syntax trees, those are basically the representation of a program, so a software project basically. And it basically allows you to easily manipulate the source code of the program without worrying about things like styling. Basically, non-semantic things become a non-issue because the formatting step comes later. So you just get only the tokens to manipulate. So in this case, I'm reading in loose mode. I get it. Check that it's an object. And then I use a tree begin update to get a recorder. A recorder is basically, think of it like Git, basically where you do changes using the recorder, but they're not applied until you commit it. So if you look at the end here, I got commit update, which is basically I record changes to the recorder, which is tells the recorder I want to apply these kind of changes, but until I commit them, nothing is going to happen. All right, so the first step I do here is I apply the TS strictest settings. So this in this case is a subscript. So I have a list of all the settings I would like to set to true. Some of these settings basically fall under strict, but I want them to be explicit so that I can choose to turn some of them off as needed. So everything here is going to be set to true. The same thing goes to on the Angular compiler setting. In this case, it's just the two settings. So in case somebody creates a project and forgets to apply this dash strict, this schematic here is gonna apply it for me. All right. So let's try running this. Let's try running this on this project. As I said, if I look again at Git status, it's nothing there. And close this window to carry connect. Close the side menu. All right. All right. So if I go ng-add and point to the project I have, so this project is K30 ng-starter. Leaves. I can do a relative path and OSS K30 ng-starter. As I said, I'm not pointing to any schematic because ng-add is going to look for the ng-add schematic. So if I run that, this is running, so it's been rebuilt after. Good. If I run that, should accept to see a modified tsconfig. Let's give it a moment there. All right. So this says it has updated tsconfig base JSON. Let's look at the Git if here status. So this tells us that three packages have been changed. All right. So if we look at git if, by the way, I'm using a Git plugin called diff. So fancy if you're wondering why this is looking so nice. Here I can see that here's config base below here suddenly added all the properties weren't there before. Same goes for the Angular compiler options. The strict template basically is a collection of that turns all these on. But again, as I said, I like to have them explicit so I can choose which ones I turn on and off depending on the complexity of the project. All right, so as I said, this is working. Now let's, I'm going to remove the changes here and then there's nothing. I'm gonna enable the next one, which is adding Prettier. All right, so installing Prettier, what does that entail? Let's look at the code a little bit. All right, so here I just create a map of the properties I want to install. I'm explicit about the versions I use. And then I just loop over them. I use another utility function to get basically the current package from the or the current dependency in the tree. Check the dependency version matches what I want. And if it does, I just skip over it. And if it doesn't, I use another utility function, add package JSON dependency, where I basically provide the properties, the key values from this map here as values. And then I tell it to overwrite if there was a previous version, I want it to be overwritten. Once that is done, I also have some configuration files to deal with. This is another concept. So schematics have a concept of templates. So in this case, here I have 2 templates. These are just files, normal files with the contents that I want. And then I use the apply function, utility function. I give the URLs of the files, and then I pass the apply template function. This one is the one you use when you do when you generate a new component using Angular generate. Usually you pass in the functions that are used to transform the templates. So templates are placeholders so that your values can override the placeholders. So if I had anything to configure, I would pass the functions here, and then I would change the templates to reflect that. Again, looking at the Angular schematics, you basically see how that works. And then at the end, I move the files to this path. So in the case, I'm moving the files to the root directory of the project. What this does, it creates a new tree. So at the end of it all, I have to merge that tree with the existing tree. That's why I call merge with, and I pass in the Prettier config source. And basically, that's all there is to it. So let's see. That's good. Here, I'll just enable this too. What I want to do is at the end of it all, I don't know if anybody noticed that after when you do an ng add, it actually installs the dependency, basically the schematic as a dependency in your project. But I'm using this dependency just to transform my source code. I don't want it to remain as a dependency. So at the end of it all, I want to remove this package as a dependency. So there is a helper function called remove package JSON dependency that I can call and pass in the name of the dependency. in package JSON, I called my project ng-starter. Should I call it Cat30 ng-starter? But in this case, since that's the name I use in here. And then at the end of it all, I add a new task to the schematic. That's a new concept too. Tasks are things that the schematic can do for you. And as far as I know, there are a limited set of tasks that you can call. In this case, we're calling not package install task. What this is going to do is basically is going to figure out what package manager you're using. So you're using npm, it's going to use npm. If you're using yarn, it's going to use yarn, and then it's going to install the dependencies for you. And since we've just modified the list of dependencies, we actually haven't installed anything. So we basically call this to install the dependencies. Right, so I'm just going to run this quickly. I'm running out of time. Again, git status to make sure everything is clean. Run the command again. And I would expect this to result. All right, so it's added the files here. It's changed the tsconfig base JSON. It's changed the package JSON, and now it's installing the packages as a consequence of the task to be added. Everything's successful. Now we look at the diff. I can see the files that have changed. I can do a git diff here. And then look at the hands. So as you see now, there's no dependencies to ng-starter because it's been removed. The added packages, the ts base config, and they unlock to reflect that. All right. So my message to you is don't let, just because there is not a lot of documentation or it seems a little bit hard to dive into schematics, if you have a problem that you need to solve and you deem schematics to be a good solution for it, don't let it discourage you. There's a lot of people using schematics now that you will find references to what you want to do, and there are people ready to help. If you have any problem regarding to what I just showed, I'm happy to help out. You can reach out to the Angular team or just post, ask the community. There's help to be found. All right. And that was my time.
All right. Thank you so much, Fabrice. Let's see if there are any questions. Homer says that was very informative. Thank you. Got thumbs up. Brandon loves schematics. Yeah, he and Tim are mostly in charge of schematics in Direct's project.
Awesome.
Let's see if we have any questions. But while we're waiting for questions, I'll have, I guess. Oh, there's one already. Okay. Are there any utility libraries to make using them easier?
There is one I found. I think it's called schematic-utilities. If you Google that, you should find that. It's basically somebody who basically took together the basic utilities from Angular and kind of builds some helpers on top of that. So that's something to look into, definitely. And I guess it's also kind of a challenge to the Angular team to see if it's easier to create some high-level APIs to make it easier to do some common things. Kind of like everyone looks through the community and say, okay, what are people doing with schematics? What are the common themes? And build some higher level libraries. Actually, the community can do that too. So it doesn't have to be the Angular team doing that.
Yeah, nice.
Yeah.
From me, I guess the question, well, okay. Okay, this is another good question. What else have you used the schematics for?
In my case, really, this was the kind of my my first to say contact with schematics. I haven't done anything more than this, but I said in my own journey, I like to have a challenge. So because I had a need, then I found the need to kind of dive deeper and try to get to know. And then as soon as I did that, I started seeing things like, oh, wait a moment, I can do that. I can do that. Then, then becomes fun to work with and just trying to figure out how can I break this? Then you just get it, you get going. So I'm still in my early kind of days, and there's still a lot on my list of things to do on the project I just showed.
Nice.
Yeah.
Awesome. All right. So the other question we have is, where do you keep them? NPM or local or schematics themselves?
So the project I showed is still local, but I would assume you can basically have it as either a private NPM package or a public one, whatever, because then as soon as you do ng-add, it's gonna basically look to NPM and download the project. So you can, I think it depends on your situation, but I would say mostly if it's something open that can be used by a lot of people, it doesn't have to be that. You can put on NPM and be ready to go.
Nice. Awesome.
Yeah.
All right. Don't think we have any more questions. I know it's pretty late in Norway right now, right? It's what, almost midnight right now?
Yeah, 11:30. Yeah.
All right. Thank you so much for coming and sharing your knowledge with our AngularToronto audience. And that, see who's next. Next we'll have Kate. Let me add Kate. Second. Hey, Kate.
Hi everyone.
How's it going?
Good. How are you?
Good.
Yeah, that was a great presentation. I actually haven't done any schematics yet. I only use them, so that's why I had a question.
Nice.
So my presentation is going to be about clean code. So I'm going to share my screen.
Yep.
And stop me at any time if you have questions, because I'm going to try to make it as as light as possible, because I was planning to let's see where. I want to make sure my notes are on my other screen. 1 second. No, not there. Okay, over here. All right. Sorry, I'm also I'm on a new computer, so it's a little bit. All right.
All right.
So
you got the stage.
I got it. Yes. Thank you, Alex. So the reason I came up with this talk was kind of a pain-driven. I started on the project where I encountered this code, and basically based on my experience and working on like a holiday one weekend, I figured if I share that with everybody or with anybody, it might help someone have clean code on their project. So I'm going to talk about how to use container presenter pattern. And at the end, we will do some refactoring of, well, actually, I was planning to do refactoring of the code, of bad code, but I'm not sure if I'm going to have enough time. I have refactored that bad code last night, or so we'll either do a little bit refactoring and just go through the changes. We'll see how much time we have. So that will be towards the end. So when we do refactor the code, we will have smaller templates. When we have smaller templates, it's going to be easier to make changes. And in my experience, it actually produces high quality code, which is just easier to test, especially when you write unit tests. So if you if you're asked to if you have to deliver a product and you're writing unit tests and your templates are small, hopefully your product is going to be creating less tech debt. And usually I call refactoring is like cleaning your house. You want to keep your house clean. Usually all it costs to do that in the house is just, your time. Not too much money, but on the project, it's usually, product owners that have to pay for tech debt. So it's not the same. But let me just quickly introduce myself. I'm a full stack developer. I've been programming for over 20 years. I currently work on a project for a client, and I work on the portal for performance and compensations team. And we work on Angular 8, and the next project is Angular 9. I've started with Angular about 5 years ago and just kind of fell in love with it. I'm trying to keep my consulting to just Angular right now, even though I have to do backend stuff too. Therefore, I'm a full stack developer. I'm also a mother of 5 children. One of my children is all grown up, so I call it in production, and 4 kind of still in development. So I stay busy with that, and and continue to work on my career, and I can't stop doing that because I really enjoy it. So I'm teaching my kids to maybe take it after their mother and father, because we're both in IT, and hopefully one day they'll be as good as their mom and dad. We'll see how it goes. And I have a small group of women. I want to give a shout out. I think we have one of the ladies from my Facebook group where I do a little mentoring for them to break out into programming. I have 3 daughters, and encourage them to learn how to program. So hopefully, this talk will kind of give them some hope that this is possible, even though I'm not great at presenting, I don't think. But let me just go through the summary of this talk. We are going to talk about some of the problems that bad code presents. Not bad code, but when you don't have clean code, basically, and some of the anti-patterns that we would like to avoid when we are writing the application. So those common problems actually prevent you from have quick turnaround on your development. So specifically, container presenter patterns been helpful in my everyday job. I usually try to see where I can break up some code and have smaller components. And I will show you. So about state management. The reason I kind of started this this whole talk is I actually implemented NGRX into our application, and I just want to say that before that's kind of what I had to do before actually adding NGRX into our application. I had to do a lot of cleanup and refactoring on some of the big components that we had, just because it was just too hard to add something as complex as NGRX. So if you never add state management to your application, at least having clean code and using this pattern will give you huge gains. So the first anti-pattern I want to talk about is single responsibility violation. It's basically, the rule is objects should only have one reason to change. It should be small with minimum number of dependencies. We also want to check that dependencies do not break, the dependencies to the component don't break this principle, and there's no tight coupling. The way to spot this anti-pattern is when your component is too large. It has a lot of methods, and it could change in many different ways. For example, if user is interacting with the component, or there's some API changes, and your DOM is changing based on that. Another way is if you don't have your application broken down into features, and you basically don't have any feature modules, and your app module, app components have everything in it. So we will kind of go through how to solve this issue by breaking down the large component that we'll see in my demo. And we'll have the parent component, which will be the container, and the presenter will be the child. So I had a little analogy here on kids cleaning the room. I think I forgot what it was, but basically, we want to make sure that when they clean the room, it's they don't get distracted and just keep on task and do it, keep their clean room by just concentrating on what mom told them to do. So that's the single responsibility violation. The next one is nested logic structure. This anti-pattern is common also in large template components, and when you have this this arrow look of your ifs, basically conditional operators are used to display like different pieces of HTML in your code. So it's going to be really hard to understand the context of the template when you have something like this, and the same thing in your TypeScript code, right? So you want to avoid it as much as possible. So it's extracting logic structures out into separate components. So we want to use structural directives like ng container will help with clean code, and also with readability of your code. So my analogy here is, let's imagine the first minion is me, right? And I tell my oldest daughter, please take out the garbage. And she goes, sure. And then I come back to her and I go, honey, the garbage is still not taken out. And she goes, well, I told, my younger sister. And the younger sister goes, well, I told the younger sister. So basically my garbage is still not taken out. So no, we don't want that. So basically, that one person has to take care of it. The next one is hidden state. This anti-pattern often showed itself when there's no explicit state object. Usually it's kind of fixed with NGRX, but you don't have to use NGRX. You can just use service with the subject. Or if your component manages its own state by calculating on the fly based on the input from like an API or something like that. So at this time you would want to extract state into a service or NGRX, like I said, or so those are the two ones how I would solve it, and I will show it in my demo. And so I have a little meme here. This kid is hiding. So hidden state, and then my analogy will be kid changing a code on my door lock, and no one can get in, or they lost the key to the house, and or they, instead of washing the dishes, they hide it in the room and it's not done at the end. So that's going to be the solution to all of these issues. Hopefully will be the container presenter pattern, and it benefited me to write clean code. It will also it helps you identify beginning of a feature with a smart component or a container component, which has a clear set of responsibilities. Your presenter component will be, we call it dumb. In many cases, it will also be a reusable component. And hopefully you will write unit tests, and it will be much easier to unit test. So let's see. I was trying to find a clean pic. I wanted to take a picture of a clean room for my kids. It was not a good day for me, so I just stole it from the internet. This looks clean. This room looks clean. Okay. All right. So the container, I just want to go through what the container is and what a presenter is, and then we'll go into the code. So the container is basically, so in an application, that's going to be like your top level component. In my analogy, the parent would be the top level component, and children will be like the feature, or a feature, right? So if you have multiple parents, each parent will be like a feature in the application, and children will be your presenter components. But your container component will interact with API services. It will have in its constructor, it will have reference to the service, or if you're using NGRX, it will have NGRX store in the constructor. I like to use Facade. I don't know how everybody feels about it. I think Facade just helps me to encapsulate the NGRX out of my container components, just so my unit tests become even simpler. I don't have to mock the store. So the data is passed to the child component via the input binding, and the event emitters will send the events back to the container from the child or presenter components. And then container will decide what to do with those events and act accordingly. If it needs to call an API or do other data changes, that's what the container is responsible for. All right, and going to the presenter. So going back to the parent analogy, so the presenter is basically your child that you told your child to set up the table for breakfast. Hopefully they'll know how to set it up for dinner too, right? So you just tell them what to do. And they just report back. So in the application, presenter component will receive the data from the container component, and it will just know how to display it, make it pretty. All of the events are raised back to the parent via the event emitters. And so the decisions are, it depends what kind of decisions. If they're simple ones that you can keep within a presenter, you can do that. But if it needs to decide to call an API or not, then you want to raise an event and let the container decide on that. It could be reusable and flexible. And so if you have like a fancy drop down with like a multi-select control, you could probably extract it out into just a presenter and have it reused throughout your application. I think I have a meme for this too. Oh, hey mom, I can have it. Oh, no, it's not here. Okay. All right. So conclusion. So hopefully when you find this pattern useful, and when you follow it, you end up with cleaner code. Your components are small. You had followed single responsibility principle. You have abstracted some logic away from your components into services. And you just end up with clean code and everybody's happy. And next we will go through the code, which will be /demo. And hopefully it'll be easier than getting ready for this meetup. Okay. Let's see. And my demo is actually inspired by Alex. We decided to do a little quick demo on Toronto's beaver tails, and that's so I'm doing a little beaver tail trail stop, not a shop but a stop, and I'm not getting any feedback. Alex, I don't see you if you want to jump in and
Yay!
All right, I'm glad you're happy because I didn't get any feedback on any of my presentations, so I appreciate you coming back. All right, so I've created stack blitz for it just because I wanted to show it running with the code kind of side by side. Let me know if you see it well, or do I need to kind of blow it up a little bit more? Because I don't think I have time to.
Just a bit, maybe.
Yeah, I don't really have time to code, so I'll just switch between the stack blitz and show you the difference.
That's great.
Walk you through. All right, beautiful. All right, so this is a little shop of whatever the beaver tails are. I guess my daughter picked the charm. She really liked all of the Lucky Charms on it when she walked in when I was doing this demo. And it's pretty simple. It has like a little cart at the top. You click buy on it and the number is incremented. And at the bottom, there is like a little terminal that shows everything that you just clicked on. So the interaction is to add it to the cart. So everything just keeps getting added to this cart and to the top, right? And another interaction is if you click on a cart, it disappears. Okay, so there's really just two things that are happening in two places that it gets displayed on. So the cart and the bottom little terminal. So if you you know what I can do is I could probably paste this into the YouTube so you guys can, if it makes sense to look at it yourself. All right, so this I have an app component. Let's see, this one is the refactor one. So we want to go to this one. So this is the one that has one component. And let's check out how many lines of code I have here. I have 170.
Can you zoom the code a little bit? Thank you.
All right, there we go. All right, so this one has 171 lines of code. So we're gonna, when we switch to the refactor branch, we'll kind of see how it got smaller. So I have a bunch of things hard-coded here. There's each beaver tail is kind of its own mat cart, and it's like all of the data is hard-coded. So when I refactor it, what I want to do is I want to take this div and make it into a list component. And I could probably do this piece right here also be part of my list. And this piece right here, which is the top toolbar, I can make it into its own header component. And the bottom where the terminal is, I will make it into another, whoops, sorry. There's like a little cloud that comes with the Angular 10, and this is Angular 10. So this will be a third component. Will kind of show then the items, and there is interaction is with this remove index. There's the component itself just has, it has two methods and the list that just represents the cart. So when we're gonna switch back to the refactor branch, just kind of to speed it up because we're running out of time. So right now, so now we had 170 something lines of code. Now we have 17 lines of code in our app component. And that's pretty good. I mean, if my kids clean up their room and make the room that much cleaner than before, I'll be happy. So the app header has input total, and the cart items is an observable, and it shows the length up on the top. And the app list component has a list that's also async piped into the input list. It's listening for the add event. The cart down below is listening so for the cart, it's listening for the remove event. And let's look real quick. We're gonna look at app component. So app component has data service. I will go through it real quick in a second. And those are the two methods that it's listening to from the child component. So now our app component is the container, and all of the pieces that we have abstracted out into our child components are our presenter components. And before we go into these components, let's take a look at the service. So I created a data service that gets its data from a JSON file right now. And it's using a pool from this get data to get the items from this test data JSON. So it basically has all of the metadata. And it has two methods that because we know our application does two things. It adds to cart and it removes from the cart. And we are using behavior subject in this case for our cart items. And the only thing that we expose to the outside world for the data source are the methods, the three methods that we want to be used, and our internals are completely hidden, right? So the list of data you can only get it from this get data method. And if you wanted to change the internals, so our state is completely within this service. So the cart items is communicated out into containers via the behavior subject. It's initially set to empty. I don't have a type for my beaver tail, so it's just set to any, but ideally you would want to have an object with all the properties on it. And it creates a new array of items every time you add to cart or remove from cart. So you have a new what do you call it? A new object of that array every time. So let's look at real quick at the list. So pretty simple here, but so if you look at the list, we have a change detection set to unpush because all the changes to this template happen through the input and output. So there's really no need to keep the default change detection here. And so this is the list, and it has just one mat card, and there's an ng4 for the input list here, and it has this add method that goes out into the parent container component, and pretty much the same thing with the cart. So the cart has removed the HTML over here, and we have input, output, and one method that it emits the event with the index, and that's how it gets removed from the list. And the header, same thing. It's even simpler. It has just a total, because that's the only thing it needs to update at the top. So if we just go ahead and buy something, make it a little bit smaller. Make it smaller. Yeah, there we go. So yeah, we can continue to buy something. Let's see, our 5 is still a 5, 6, 7, and we can remove it. So everything still works. What we get out of it is we have cleaner code. Our app component is much smaller. Our template is much smaller, so much easier to maintain. One day I'll write some unit tests for it. And our data service has all of the logic in it. And that's pretty much all I have. Any questions?
All right, let's see if we have any questions. Do we have any questions for Kate? Those are really nice beaver tails, by the way.
I couldn't stop keep adding them. They're so awesome. It's there are just so many more different ones there. I better stop at 9.
All right, we have a question from CD. Why we should have on-push change detection for the presenter list? Can you explain more?
So basically, you are telling the Angular not to worry about checking the state of your objects, if they're changed or not. You're telling it, hey, I will change a reference to all of my objects within the template, and that's the only time you want to update the template. So it's for better performance. Unless there's another reason, Alex. What is if there is, I might be missing it.
No, in general, on push improves the performance. If we are saying that, hey, don't check this component's views unless any of the inputs are changed, or unless it was told otherwise with the async pipe, right? That has the detect change and all that stuff, mark for check and all that stuff. So
Yep.
yeah, that's exactly right.
Oh, Brandon has a question actually.
Yeah.
A good one.
Do you use facades for features that don't use interacts also?
Actually, I started adding facades to anything like, that has more than one service for a container component. That actually gives me kind of like a door a little bit open for when somebody agrees to add NGRX to that feature. Then that's why I can, quietly change it, swap it, and nobody notices it. But yeah, I like to use facade a lot.
Yeah. Lars just said it's a very trick question. I agree. Do you? Yes. Can you also share the stack lists when you have an opportunity to do so? We'll probably put them in the description after as well, so everybody has a faster access to that.
Mm-hmm.
That's a good one. And Balaya says that he wishes there was a flag that could be set during an GNU, which would create components with on push. You can actually probably can use some of the schematics for it, right? So we can work with that, right? And basically create your own schematics that does the on push by default.
Sure.
Brendan says not a trick. All right. Let's see. Are there any questions? I've heard this. There could be a live question from Eugene coming, but looks like it's not a question from Eugene coming.
I don't know. I don't see him. I see there's another question. What are the best practices in code cleanup?
Yes, that's right.
You know what? I think it's the same as if you're cleaning your house. Do one room at a time.
The house kids analogies are definitely the best. That's what was the my first time we were presenting Angular. Was it Angular Air?
Oh, Houston.
Yeah, oh, Houston, that's right. Brendan's asking, what's your rule of thumb for a component that's too big?
Rule of thumb. Probably one-page scroll kind of thing. Like if it scrolls beyond one page, then it's too big. That's pretty easy to kind of visual.
Yeah, I see Lars is suggesting around 100 lines of code. I typically go with that one kind of as well as close to 2, maybe 3. It's close to 3 scrolls. Then I would say it's getting too big, but yeah, one view is kind of nice. All right, awesome. Looks like we don't have any other questions. Thank you so much, Kate. I don't know if you have to run or you can stay. We'll see. Maybe people get other questions as well. But thank you so much. With that, we have our next speaker. We have Nicholas Jameson here. Hey, Nicholas.
Hi, Alex.
We cannot. Oh yeah, now we can hear you. Nicholas is a freelance front-end developer, RxJS core team, and he'll be talking about improving the developer experience with RxJS tools. All right, let me add Nicholas's presentation here. Here you go. You're presenting. Thank you so much, Nicholas. Go ahead.
Great. Thanks, Alex. My talk is an updated version of a talk that I gave last year at RxJS Live. So I've made a few changes to the tools. At that stage, they were a work in progress. I was hoping to have a beta out fairly soon after that talk, but I've done a whole bunch of other work on them. So this talk is an updated version of that talk as well as an explanation as to why you are still waiting for these tools. So we'll start with a quote, and the quote is that some people have said that RxJS is impossible to debug. So only some people, everybody else just says that it's really hard to debug. I don't disagree with this. I would just qualify it. I would say that RxJS is really hard to debug with conventional debugging tools. And thinking about this problem, RxJS isn't alone in being difficult to debug with conventional tools. There's a whole bunch of other stuff that's also difficult to debug. I mean, CSS, you can't debug CSS with a debugger. React components and Angular templates, if you declare something and it doesn't work, a debugger isn't always the best tool to figure out what's going on with that. And ESLint rules, if you're writing an ESLint rule, ESLint rules use selectors to match AST nodes, and those selectors are very much like CSS selectors. And again, a debugger is not a very useful tool for figuring out why your ESLint rule isn't working. So looking at these things, there is something that all of these things have in common. I mean, they're all declarative. CSS is declarative. The rules in ESLint, the matches that are used for those, they're declarative. Your React component, your Angular template, these things are declarative. So we have specialized tools for dealing with CSS. We use the Chrome DevTools to look at how our rules are working, to look at how they're being applied, to look at what's overriding what. We use the React DevTools to figure out how our components are working. Basically, we need to step away from the debugger and use something else. So thinking about this, do we need a different tool to work with RxJS? If we have a look at a snippet of RxJS code, we've got a form here in Angular, values changes. We're going to pluck a term out. We're going to debounce it, and only take the distinct changes. So it's obvious from looking at this that RxJS is a declarative thing. We're just declaring the behaviors that we want and applying those to an observable, which are the form changes. And if it doesn't work, the usual advice is, do something like this. You'll put a whole bunch of taps in, you'll log stuff to the console, and then look at what's happening with those logs and deduce what's happening with your program. So when I started working with tooling to make developing with RxJS a little bit better, a few years ago, I wrote a tool called RxJS Spy. And the very first thing that I wanted to do with that tool was remove the need to have to modify your code to put in this sort of logging. So the way that tool works, at the core of it, is it has this tag operator. So you can take a tag operator from RxJS Spy, you can compose it into your observable, give it a name, that is the tag, and then you can work with it using the tool by annotating your observables and your pipelines with tags. So the tool is something that you would incorporate into your application. So you would import RxJS Spy, you would set it up, and RxJS Spy would expose an object on window called Spy, and you would interact with the tool using the console. So you would have your app in the browser, you would open up the DevTools, you go to the console, and you could type in. So you would communicate it with RxJS Spy using the command line. You could type in RxJS spy.show, hit enter, and it would give you a bunch of information about all of the subscriptions that it had seen. So it would tell you how many subscriptions you've got, the tags to which they're subscribed, the value counts, the number of values that have gone through those subscriptions. It'll give you the stack frame so you could sort of poke around and have a look at it. So it's a whole bunch of stuff that's more easily available, and you could sort of poke around with it and you can see more of what's happening in your application. You could also switch on logging. So once you've got things that are tagged in your application, you can go to the console and switch on logging. You don't have to manipulate your code. You can switch on the logging for people, and it will tag the notifications, log the notifications as they're happening. And there's a mechanism there where you can undo the thing. So you can switch logging on and off on a tag basis. The other thing you could do with it is you could pause observables. So with a tagged observable called people, you could call pause. It would give you a deck. Using that deck, you could step over a notification. You could skip notifications, and you could resume. So it would just play the notifications that have been paused. So this stuff was pretty useful. You could inspect the observables that were in your application. You could interact with them, and the show gave you some degree of visualization, but not a great deal because it's pretty much a command line tool. So there are things that could be improved with it. So I did start thinking about the way that we could write a better set of tools for RxJS, ideally so that we didn't have to use a tag operator, so we didn't have to make any changes to our code. Also, so that we didn't have to include RxJS Spy or something equivalent to it in our app. So rather than sort of importing something in our app, it would be nice to not have to do anything like that. And something where we could actually visualize what was happening with subscriptions. It should also be discoverable, because being a command, essentially a command line tool, RxJS Spy was pretty constrained in terms of figuring out how it worked. You'd have to know what commands you were going to run. You'd have to go to the console. You'd have to type it in. It was not the most straightforward thing to use. So what I wanted to do was write a dev tool, something that integrated with the Chrome or Firefox or Edge dev tools, gave you a panel in the dev tool in which it would display all of the information about RxJS subscriptions in your app. Now, the way dev tools work, this is just a high-level sort of overview of what happens, is you have a dev tool in the panel, which is a JavaScript application. When you load your app, your app will be loaded into a tab. The dev tool is going to load a content script into that tab. So this is a completely separate JavaScript context inside the tab. It's outside of your application. It can manipulate the DOM. And what happens is it manipulates the DOM and essentially injects a script into your app. So the parts that you see highlighted here are all contained in the dev tools, the Chrome extension, which integrates with the dev tools. So we've got the panel, content script, and the tools. So the tools are injected into your application. You don't have to have any dependency on the RxJS tools to use them in your app. All you need to do is call patch. So the way that the tools get hooked up to your application looks a little bit like this. So this snippet of code is going to look for a particular symbol on window, which will be, that'll be the symbol that's been added to the window for the injected tools. And that symbol has as its value a patch function. So if you call patch and pass in the targets, which are the observable and the subject from your RxJS library, it will wire up your application to the tools. So that's it. There is no dependency in this case. You're just going to run, call patch if it's there. If it's not there, the tools aren't installed. Call patch, pass in the subject, and then your app is wired up to the tools. There is a small package which basically just wraps up those few lines, so you can import that rather than having to sniff out the symbol yourself and just call patch. And because the RxJS tools package is being bundled using the same bundler that's packaging up your application, it's going to have the same RxJS package that you're consuming. So in this case, you don't need to pass in the target. It's really straightforward. You just import patch, call patch if you want to wire up the tools, and away you go. So in terms of what the tools look like, this is the panel that would be shown in the DevTools. It's depending upon how you've arranged your windows, it's either split vertically or horizontally. So on the left, we've got subscriptions. And on the right-hand side, we've just got an info pane selected at the moment. So if we highlight one of these subscriptions on the left, we'll get the information about it. So the subscriptions that are on the left form a tree. We can expand them. The icons borrow from the marble syntax. So a line with a circle on it means it's emitted at least one value. So we can see the fork join at the top hasn't emitted anything. The switch map underneath it has emitted at least one. We can see in the switch map that we've expanded it. We can see that there are 3 maps inside it. If you look carefully, you'll see those map icons have a dashed outline, indicating that those are inner subscriptions. And below that, there's a take, which has a solid outline, so it's the source. So we can, just looking at the iconography, we can get some information about what's actually happening with these subscriptions. We can see that 2 of the inners have been unsubscribed, and 1 of them is still subscribed. So the information on the right-hand side gives us the same sort of information in text format. We can see that there's one open inner subscription. There are two closed inner subscriptions. We can see the first and the last values that were emitted from the switch map. You can see when they occurred, and we can see when the subscribe occurred. So pretty useful. We can get a good overview of what's actually happening in the application. We can focus on particular subscriptions, and it's far more visual than the command line interface that we had for RxJS Spy. So the other thing you can see is that each of these subscriptions that's shown on the left-hand side has on its right a small circle with a chevron on it. So what those are, if we expand that open, we've got a bunch of commands that we can use to switch on logging for each subscription. We can take a snapshot of each subscription. If we click on the snapshot's value, we can see all of the values, all of the attributes that are accumulated for that snapshot by the tooling. Tagging is still available, so you can give a name to a subscription. The tag operator still works if you want to keep using the tag operator. It's possible to pause subscriptions, so we can do the same sort of pause that we did with RxJS Spy, and you can step over things. And then you can resume. Now, the other thing that is shown in the logging tab are warnings. So in this case, we've got a zip operator. Zip is going to take values from multiple sources and emit them combined, but it waits for each source to emit before it emits the combination. So if you have a slow source and a fast source, you have a potential buffering problem where you go to an open-ended buffer and you're going to be accumulating values from the fast source at a greater rate than the slow source. And it's useful to find those situations, and the tools will warn you about those. So they'll give you a warning for buffering and for a bunch of other different things. And those warnings show up in the log panel as yellow. So you can click on those and you'll see it'll highlight the subscription that has the problem, and it'll expand the tree. And the highlighting and the expansion works using the search bar. So if you look up the top, you'll see that it's got buffer count is greater than or equal to 100. So that's the limit, the default limit for the warning for buffer counts. So this is using the search functionality to link the warning to the zip subscription that's in the tree. So you can use the search functionality in a manual way as well. So we can type in a bunch of things. We can type in things like operator names, and we can select the operator. We can type in the source names like a subject. We can also type in the IDs internally. IDs are used for observables and subscriptions, so you can search based on ID. You can also search based on files, so you could search for subscriptions that are made to observables that are in a particular file. Now, these searches are just JavaScript expressions, so we can combine them. You can search for things that are in a particular file that are complete or incomplete, or we can search using any of the other attributes that are collected in the snapshot. So value counts, whether thing's hot, whether it's cold. It's really quite powerful in terms of what we can do with this sort of searching functionality. So the tools have several advantages over RxJS Spy. There's no dependencies at all. There's no overhead. So you could leave the patching switched on in production if you wanted, and you could use the tools to debug and inspect production applications. We've got a visual representation of the pipelines. We've got discoverable features. We can see everything in the user interface. So we can see our subscriptions. We can highlight a subscription. We can open the button, open the command panel that lets us log and snapshot and pause and do all that sort of stuff. And we've got queries. So we can do fairly powerful queries in terms of finding observables based upon subscriptions, based upon their properties, their names, their states, the number of values they've emitted, the types of values. Pretty useful stuff. So in terms of what I've been doing with the tools for the last year or so, since I gave this talk in Vegas last year at RxJS Live, the user interface has changed completely. I've made it a great deal simpler. The tools that I showed last year didn't have integrated logging. The logging was logged to the console, so you would have to split the dev tool, you'd have the console underneath, you'd have the dev tool at the top, and you would get more conventional logging with the console. The logging is now integrated, so we can log a history of notifications. We can switch them on and off and we don't lose them. That's as you would if you cleared the console. But the most sort of wide-reaching change that I made in the last 6 months has been performance-based. The original version of the tools took RxJS Spy, and RxJS Spy is this, the backend for RxJS Spy is essentially what's injected into your application by the tools. So when you load your application in a browser that has the tools installed, the dev tools loads the content script, and the content script injects the tools into your application. Initially, that blob of JavaScript that was injected into the application was essentially RxJS Spy. Now, there were performance issues when you ran it with either an application that had a large number of observables or an application that had observables that emitted at a very high frequency. So with RxJS Spy, the snapshotting was done essentially on demand. So when you went to the console and you typed in spy.show, it would take a snapshot and it would show you the contents of the snapshot in the console. So the initial version of the RxJS tools used that mechanism and took snapshots when things changed, and then pushed that snapshot through to the developer tools and would show you the information in a tree. Now, there was just too much information that needed to be moved every time a snapshot was taken. So one of the things that's changed is that it no longer works that way. The backend, what I call the backend, the injected tools now send only what's changed when notifications and subscriptions and those sorts of things occur in the application. So it's much more performant. There's a lot less information that needs to travel back and forth. But to make that change involved refactoring pretty much everything that was in RxJS Spy. The last thing that I've been working on has been making the configuration of the tools as straightforward as possible. So what I wanted to do is have the ability to just switch these things on and off very easily using Angular. And it was really quite timely that I listened to Fabrice's talk today, because one of the things that will be happening is that for the Angular configuration, it'll be entirely based on schematics. So you'll have a schematic that lets you switch on the RxJS tools, and when they're switched on, that'll be it. You don't need to change anything else in your application. There'll be no code changes whatsoever. So have a quick look at how that actually works. When you're compiling TypeScript into JavaScript, your TypeScript runs through the compiler and then it outputs JavaScript. One of the things that you can do with the TypeScript compiler is you can use a transformer. And what that lets you do is, in your transformer, you can manipulate the AST to change the output of the compiler. So down the bottom, you can see the output's changed. We'll just focus on what those changes are. So this is what would ordinarily be output from the TypeScript snippet that we had in the previous slide. So what the transformer does is it adds an import, which imports a development file from RxJS tools transformer. And what that will do is it will patch your application into the tools if it hasn't already been patched. The second thing it does is it wraps sources and subscriptions and operators in small functions that add some context and also capture the names of what you've got in your program. So those functions get added down the bottom of the file. You can see they capture whether or not it's a core source, whether it's a core operator, the name, the temperature, that sort of stuff. And those functions are basically just going to call lower level functions that tag some information onto the observable using a symbol. So the main reason for doing this isn't just convenience. The thing is with RxJS is that there's a whole bunch of operators that are implemented with other operators. So in RxJS Spy and in earlier versions of the tools, what used to happen is it would interrogate the observable, the subscriber, that represented an operator. So in RxJS, in the core, map the map operator has its own map subscriber, and that map subscriber is a class, and that class is named map subscriber. So RxJS Spy and the tools would try to figure out the name of the operator based upon the name of the subscriber. So with map subscriber, it's fairly straightforward. You just take subscriber off the end. It's called map. So, you know, it was the map operator. So you can represent that in the tree and it sort of all makes sense. The problem is that using that technique gives you some very strange names. You might be looking at an observable, composed observable, and you might be quite surprised to find that instead of the switch map, instead of the start with that's in your code, it shows up in the tool as merge map. It seems really bizarre, but switch start with is implemented with concat map, and concat map is implemented with merge map. So the whole thing gets really strange. So being able to use a transformer to capture the actual name means that you get the correct names for the RxJS operators. It also means you get the correct names for any user operators and any user observables. It also captures the context, captures the function in which it's called. So when you are querying it, you can query it on the file that it's in. You can query the function that it's in. And the other thing that it lets us do is using a transformer, we can not only just add information to instrument and to capture the context and the names for the application, we can also remove information. So the transformer, when it's running in dev mode, it will add these functions and it will capture the names and capture the context so that you get an accurate representation of your observable, your composed observable in the tools. But in mode, it doesn't do that. But not only will it not do that, it will also remove any tag operators. So using tag operators is still useful because you can give your parts of your application very specific names. So instead of having to say search, you know, I'm building up a query where you're searching for something that's in a particular file and a particular operator that's in that particular file or a particular observable that's in that file, you could search for a tag. So you can give something a name that makes perfect sense for your context, for your application's domain. And you can use those tags to work with the tools, knowing that when you do a production build, those tags will be removed. So you'll have no performance overhead whatsoever. So that's what I've been working on. The tools this time are very close to being in a beta. There's a URL that's there. If you go to that page, there's a mailing list. One of the things I'm going to start doing soon is sending out a newsletter detailing where the tools are at, how the progress is going, and also how you can use the tools to solve particular problems. So that's my talk. Hopefully you've got some questions for me, and I hope this has been useful.
Thank you so much, Nicholas. Yeah, I've been very excited, and I was very sad that I, will miss your talk from Las Vegas. It wasn't uploaded to the YouTube, so I've been bugging you about this for a long time. Thank you for actually doing the talk for us. I personally learned a lot from you, and I'm very excited and happy to have you at AngularToronto, so you can share the knowledge with everybody, all our attendees. Let's see if we have any questions for Nicholas. Yeah, mind blown. Yeah, I kind of agree. Now, first question is, so first question is, can we have this yesterday? Yes, it's probably a lot of work, and
yeah, well, most of the big parts are done. There have been other things that have pushed me off track lately, as you could sort of understand. But the refactor was the big one, changing it so that it just works. The main reason I didn't want to release it is because I had hoped that it wasn't going to be such a performance issue. and that it would work with just injecting the SPI into the application, and that things could be refactored and redone at a later date. But it really was quite crippling when you put it into a large NGRX application and that sort of stuff. The amount of information that needs to move back and forth across the communication channel, because when the app communicates with the dev tools, it has to package up the entire snapshot as JSON. Each of those things that you see, in fact, there's another one as well, because there's a background script. So your app goes to the content script, then it goes to the background script, then it goes to the panel. And each of those is a step through a different JavaScript realm, and shoving this huge amount of JSON around each time was just not going to work. And that JSON in the SPI, you can see, and when SPI outputs stuff to the console, it includes the stack frames. So that blob of snapshots that went across this communication sort of pathway each time included the stack frames, which included the files. So it was really big. So rather than sort of just try to get it working by cutting down the volume, I decided it made proper sense to actually refactor it and do it properly, so that information is only sent across when things actually change or when it's requested. So the queries both ways when you are looking at the snapshot. So when you log something to a snapshot and it goes into the log window, and then you click on that and it shows you all of the information in the tools, that's actually a query back into your application, which gets that information for tools and then returns it back to the SPI. So yeah, it was just not going to work very well for people if it wasn't performant, and if it's so slow and so clunky, it was just not going to happen. And the other thing was that the name issue was something that was very confusing as well. So I think to release something that was slow and didn't really work that well and had very confusing names because you lost your custom operators, and because things like start with had really bizarre mappings to merge map, it was really quite strange. I mean, it confused me looking at the tree of subscriptions that didn't sort of make any sense, and seeing merge map there and then looking at your code and there's no merge map in your code. It was baffling. So most of the hard work's done. I just need to tweak the colors a little bit and see how we go in terms of getting it accepted into the Chrome App Store. But if you do have a look at that link and subscribe to the mailing list, before it's actually publicly available, I'll be doing a beta, and the beta will be invitation. So if I've got your email on the mailing list, there'll be another email that goes out. And if you confirm that you actually do want to use the tools, then I'll make it available to you via your email.
Nice. Yes.
Not yesterday, but soon.
Yeah, I'll definitely want to try it. There's a related question to the topic that we're touching on right now. Is it going to be open source?
It's not open source at the moment. I have to think about exactly how much of it I will open source.
Sounds good. Because for example, if we would want to use it, some of the corporate environments, they block the extensions, right? That are just downloaded from externally. For example, the same practice goes within Google, and some of the things for us to use it for that code, same as, for example, Redux DevTools, we had to basically build it our own, basically get the code, build our own, and push into the local internal Chrome extension store. So we can, because that one basically is code is analyzed and made sure that there's nothing. Of course, there would be nothing, but it's just, depending on the APIs that the extension requests. Nice. Okay, so let's see what other question we have. Can you see? Can you manage spot, debug memory leaks or unwanted subscriptions when you have multiple subscriptions from the same observable through the tool?
Yeah, you can just you can run queries that will tell you the number of subscriptions that you have to a particular observable. You can run queries that will tell you based upon the age of the subscription. You can combine them, so you can have queries that are based upon the age of the subscription, the number of times that subscription is actually emitted values. One of the things that I will be working on is just building up a predefined list of useful queries, so that you don't have to type these things every time, so that you can have a query which is, find me style subscriptions, that sort of stuff. But yeah, it's quite powerful in terms of what you can do once you build up a query using a few of these attributes that have been collected in the snapshot.
Nice. Let's see if we have any other questions. I don't see any. I'm very excited about this extension. I mean, this is something for me. You know, tab console log is like a very frequent thing that I have to do, especially since if it's in Jurex, it's at least we have Redux DevTools that show all the actions and stuff. But for example, something with a component store that we are having right now, which is a smaller thing that it doesn't connect to any Redux DevTools. Something like RxJS DevTools would be really awesome because it would be mostly wiring that all up. And unless otherwise it's just pausing and their breakpoints and maybe trying to get into it. But then again, if there's no bodies or functions, right? You can't really even debug it with the breakpoints. You have to refactor some of the things. So yeah, I think it'll be a fantastic thing. Thank you so much for presenting it to us. All right. Since we don't have any, I don't see any more questions. I'll do the last few slides as I typically do for the AngularToronto meetups and for the in-person ones. So again, thank you so much, Nicholas. Thank you, Kate. Let me just skip here. All right. So I'm typically on every after every meetup, we'd like to get the feedback. So if you watched it or in replay, we'd like to hear the feedback. For example, here's some of the feedback that we heard last time that hope that future meetups will also be available online. Somebody lives 2 hours away, so virtual attendance possibility, right, or replay. For those who could not basically get into Toronto, that was the first meetup that we had online. After we couldn't do any in-person ones. Also, somebody said that they love the online format. It allows for engagement and asking questions, and it was awesome to see others jumping in and answer questions. We didn't have too many questions. We had a very good number of questions actually. Some of them very good. So please leave those feedbacks at ngtoronto.dev/feedback-july-2020 if we would like to hear it and maybe improve it any further. Oops. The other one is, let me see. The other one is if you would like to speak at any of our events, please also apply ngtoronto dev-speak. Would like to have local speakers as well. This was actually the first Toronto meetup that we didn't have a local speaker. We had somewhat local. Kate is in Illinois, so it's not too far, but still, I would like to have also Toronto speakers. We can help with some feedback of slides, choosing topics, and yeah, it'd be great to hear from locals as well. And the last one is Angular Toronto next meetup. I will have probably around in September timeframe. It will be probably online. Looks like we'll have the online format until the end of this year. We'll see how that one goes. Although Ontario is reopening more and more, office space used for any events internally, something that would be not business critical might be delayed for until further time. So looks like September 1 will also be online. So keep an eye on that at meetup.com. All right, that would be it from me. Thanks again for coming. Thanks again for watching. Please provide the feedback, and see you next time. See you.